Hello and welcome. This is going to be our homework help video for the quadratics, inequalities, systems, and with complex solutions. Homework. First set of questions asks us to solve each equation by taking square roots. So the instructions tell us to solve by taking square roots, but we can also tell that that's going to be the easiest way to solve a lot of these because they don't have a linear term. They don't have a b value. So we can solve by just taking square roots. It's a way we can undo the squared, and no b value will get in the way. So if I, in number one here, just take the square root of both sides. On the left-hand side, that square root will cancel with the squared, leaving behind v. On the right-hand side, I'll have the square root of negative 67. Now, I can take that square root of negative 67, and I might want to write a plus or minus in front of it, just to remind myself that square roots are both positive and negative. I can take the negative 67, I can split it into a negative 1 times a 67. Once I'm at this point, I can distribute that square root to both of these. Square root of negative 1, square root of 67. The square root of negative 1 is this new number we just learned about. It's I. I is equal to the square root of negative 1. So instead of saying the square root of negative 1, I'm just going to say I. I'm going to put it at the end. I'm always going to put I at the end if it is part of my answer. So plus or minus the square root of 67I. Let's try this with a problem like number 3. In number 3, I can subtract 10 from both sides. I'll get x squared equals negative 24. Take the square root, take the square root. X equals the square root of negative 24. The negative pops out as an I, and I'll get that x equals plus or minus root 24I. And this is a fine answer. In the answer key, you might see this a little bit different. They factored a 4 out of this, and the square root of 4 is 2. So you'll see plus or minus 2 root 6I. But this is fine for right now. So just go with this. Number 5, no b value, so I know I can solve by taking square roots. I'm going to move everything away from my variable. I'm going to do that by adding 7 to both sides to start. Moves this number away from the variable. Now I've got 7n squared equals negative 20. I'm going to divide both sides by 7. That gives me n squared equals negative 20 over 7. And then I'm then going to take the square root of both sides. N equals plus or minus root 20 over 7i. Again, this can be simplified further, but I'm fine with you leaving it like this for right now. Unit number 5 is all about radicals, and we'll really learn how to simplify things like this. But this is fine for right now. Let's see if there's another one that would be good to do. Let's do number 8 real quick. Number 8, I'm going to add 6 to both sides, again, moving everything away from my variable. I don't have a b term, so I don't need to use quadratic formula or completing the square or factoring. I can just use square roots to solve this. 5m squared equals 45. Divide away my coefficient. Get that m squared is equal to 9. I'm going to take the square root of both sides. And I'll get that just m equals plus or minus 3. The square root of 9 is 3. No need for an I in this one. This is just a real number. No imaginary part necessary. So I think that should be good for the first set. Finish up the rest of those. You'll be golden. Question number 9 asks us to solve each equation by completing the square. When I'm completing the square, the only thing that I need to get started is I need to make sure that my a value is 1. Otherwise, I got to divide by that a value to get an a value of 1. But fortunately, in 9, 10, 11, 12 here, the a value is always 1. So I'm ready to go into the structure of vertex form, which is going to help me solve this equation by a technique called completing the square. So I put a v there, put some parentheses. This number here, always half of our b value. So this is going to be a minus 9 squared. Now that minus 9, it's going to give us some extra. It's always this number squared. Negative 9 squared is 81, so we want to subtract away 81. Then we want to keep every other number that's in the original equation. So just let me explain this real quick. V minus 9 squared, if I was to FOIL that, I would get my V squared back. I would get a negative 18V back, but then I would get an extra minus 81. That's why we get rid of it here, because this gives us extra, in addition to the two terms that we wanted. All right, let's go ahead and combine our like terms. Get V minus 9 squared plus 29 equals 10. Let's subtract 29 from both sides. Get V minus 9 squared equals negative 19. Take the square root of both sides. So the whole point of doing this, completing the square procedure, is to get the whole side to be squared so that a square root can just cancel out like that. We couldn't square root at the beginning. It doesn't cancel when there's subtraction and addition. But now the whole thing is being squared. So if we square root the whole thing, those cancel. And I'm left with V minus 9 equals the square root of negative 19. That negative is going to hop out as an I, and I'm going to add 9 to both sides. Give me my final answer, V equals 9 plus or minus the square root of 19I. Don't forget, square roots are always plus or minus. And so if I write it, that shows me where my two answers are coming from, since all quadratics should have two answers. Oops. All right. Do we need to solve another with completing the square? Let's see, this one work out well. Let's just take a look. No, none of them have all rational coefficients, so I'll let you just work on those ones. Let's solve with the quadratic formula. I'll do number 13, since there's a little trick with 13 to make our lives a little bit easier. If I ever want to use the quadratic formula, first I should copy down the quadratic formula. The quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a equals x. And then I need to get my equation into standard form so that I can just plug the a, b, and c values into this equation. Number 13 is not in standard form. I need to get one side equal to 0, so I add 12 to both sides. Now I've got 9b squared plus 12 equals 0. I'm going to divide both sides by 3 to make my life a little bit simpler. So if you've got a common factor, might as well divide it away so you're dealing with smaller numbers. This gives me the quadratic 3b squared plus 4 equals 0. I'm going to plug in 3 for my a value, 0 for my b value, and 4 for my c value, all into this formula here. Let's see what that looks like. Negative b will be a 0, so I'm not going to write it. Plus or minus the square root of b squared, again, I'm not going to write that, minus 4 times a times c all over 2 times my a value of 3. This equals plus or minus the square root of, let's see, that's negative 12, negative 48 all over 6, which equals plus or minus the square root of 48 times I all over 6. And we'll just leave our answer like that. The square root of 48 could be simplified because it's got perfect square factors, but we're not worrying about that yet today. Sketch the graph of each function. So here we've got some quadratic inequalities. These are in vertex form, so I can straight to sketching. I'm going to put a point at my vertex of 1, 3. Always flip that first sign. The vertex here is definitely at 1, 3. Next thing, I'm going to copy down my pattern 1, 4, 9. So I move 1 unit out, I should move 1 up. But this is telling me if I move 2 units out, I should move 4 up. 1, 2, 3, 4. Now I need to make a decision on what type of line I want to use to connect up these dots. This inequality does not include the or equal to sign, so I'm going to use a dotted line to connect up my dots. Something like that. Still not done. Next thing is I need to shade to one side of this parabola. Well, again, we check the symbol. The symbol says that y is greater than. Greater than makes me think above. And that's accurate. I need to shade above this parabola. All right, what if the equation is not given in vertex form like number 19? What should we do? Well, let's convert it to vertex form. I'll start by multiplying everything by -2. This will get my a value to be equal to 1. That'll be very useful. So -2y, just multiply by a negative, so I should flip my sign. It's greater than or equal to x squared minus 4x plus 8. -2y is greater than or equal to x minus 2. Where'd that -2 come from? It's always half of this one. Squared minus 4 for the extra, plus 8 for what was in the original equation. I'm going to combine my like terms. -2y is greater than or equal to x minus 2 squared plus 4. Divide everything by -2. And I get that y is less than or equal to, so send it back. -1/2 x minus 2 squared minus 2. So where's the vertex of this parabola? Well, it's always at h comma k. H is 2, k is -2. So at 2 comma -2, I need to have a vertex. Now let me copy down 1, 4, 9. I'm going to go a little bit further. 4 squared is 16. 5 squared is 25. Now I'm going to manipulate them by my a value. So I'm going to multiply everything by my a value. That 1 is going to become a -0.5. The 4 is going to become a -2. The 9 is going to become a -4.5. The 16 is going to become a -8 when I multiply it by -0.5. Negative. So from our vertex, if I move 1 unit out, I should just move a ½ unit down. If I move 2 units out, I should move not 4, but -2. 2 units down. If I move 3 units out, 1, 2, 3, I should move 4½ units down to get back in my graph. 1, 2, 3, 4 and a half, just about there. This has the or equal to, so I'm going to connect these up with a solid line. Just like that. And now I'm going to shade. This is a less than, so I'm going to shade below this parabola. Purple. That's the graph of this inequality. All right, solve each system of equations. Show your work on a separate piece of paper and attach. If you're watching this video, I will tell you number 20 right now has no solution. Don't rack your brain over it. You can give up on number 20. Let's do 24 and 25, and then we'll call it good on this homework help video. You should be doing this on a separate piece of paper, so you've got room. Let's take a look here at 24. I want to solve this system. I've got a quadratic and a quadratic. So I'm going to have to do some substitution, but let's substitute for y. So I'm not substituting into something where I'll then have to square what I just substituted in. Sometimes you won't be able to avoid that. But if we solve, I'm going to solve for this one because it looks like it's got smaller numbers. And then I'm going to plug it in here. So yeah, let's say plug in. So maybe right here is fine. Negative x squared minus 4x plus y plus 2 equals 0. Time to get y by itself. We can just subtract y from both sides. Get that negative x squared minus 4x plus 2 equals negative y. Divide both sides by -1. And I'll get that x squared plus 4x minus 2 equals y. Let's plug that into the second equation, in for y, this whole thing, and see what we get. We'll have to combine some like terms. So negative 15x squared minus 60x plus x squared plus 4x minus 2 minus 54 equals 0. So I plug that in now. I've got only x's. Time to combine like terms. This negative 15x squared and this x squared are going to become a negative 14x squared. This negative 60x and this 4x, that's going to become a negative 56x. And this negative, or this negative 2 and this negative 54 are going to become a negative 56. All right, is there a common factor I can divide out of everything? It looks like 7 will fit into all of these pretty evenly. So I'm just going to divide everything by 7. And I'll get that. Actually, let me make that a negative 7. So my a value becomes positive. So 2x squared plus 8x plus 8 equals 0. It looks like everything's still divisible by 2. So I'm going to just divide everything by 2. Then I get that x squared plus 4x plus 4 equals 0. Two numbers that multiplied to be 4 but added to also be 4 are x plus 2 and x plus 2 equals 0. I only need one copy of these after I apply the zero product property. And I can just set one of these equal to 0 since they're identical. X plus 2 equals 0, minus 2, minus 2. X equals negative 2. We're not quite done yet. I've got to plug that in someplace. I'll choose right here to plug that in, solve for my corresponding y value. And I'll get negative 2 squared plus 4 times negative 2 minus 2 equals equals just y. So now I get negative 2 squared, that's 4. 4 times negative 2, that's minus 8. Minus 2 equals y. 4 minus 8, that's negative 4. Minus 2 is negative 6 equals y. And I'll write this as an ordered pair. Negative 2 comma negative 6. I'll always double check by plugging it back in to make sure we don't have an extraneous solution or made a mistake. Let's just see if we got that one right. Negative 2 comma negative 6. All right, 25 real quick. We could, just looking at 25, we could actually do elimination because I can get these x's to eliminate. All I'm going to have to do is multiply one of these equations by negative 1. And then that's going to make my life a whole lot easier. So negative y squared plus x minus 2 y plus 11 equals 0. I'll multiply everything in here by -1. I'll get y squared minus x plus 4y minus 13 equals 0. Add like terms. These will eliminate. These will eliminate. This will leave me with a 2y. And this here, when I add them together, is going to give me a -2 equals 0. We'll add 2 to both sides. 2y equals 2. Divide both sides by 2. Y equals 1. And now I got to plug that back in somewhere to solve for x. I'll just pick the second equation arbitrarily. -1 squared plus x minus 2 times 1. Oh, looks like I'm doing the first one. Oh, well, yeah. Plus 11 equals 0. 1 squared is 1, but the minus stays in front, so -1 plus x minus 2 plus 11 equals 0. These will combine to be a -3 plus an 11 is going to be an 8, so x plus 8 equals 0, minus 8 minus 8. X equals -8. So -8 comma 1. For 25, let me check to see if I did that one right. -8 comma 1. So sometimes they work out a little bit better. And because our squared term canceled, I think we just get the one answer. And that's what the answer key showed, but what I'm saying is I think this is not a double 0 right here. I think it's just the one answer, since we didn't really solve a quadratic. Since, yeah, up here, that all of our quadratic terms canceled. All right, well, keep working on this, and have a good rest of your day.